Thank you, Lee. For those of you who don't know me, my name is Noel Burton. As Lee said, I have had history with 12D. I've been a surveyor for almost 40 years, and in that time I've sort of gone through basically a non-technology type of survey right through to where we are at the moment, where I'm happily going out and using drones for most of my survey work. I called in to see Lee at one stage and he said, could you do a quick talk on how we use drones for basically people that may not use it in industry. So for the surveyors out there using drones, just bear with me if I do things slightly different to how you'd normally do them. So what I'm just going to go through is I'm going to go through a bit of a PowerPoint which will have some videos embedded in it, talk about some of the drone types, or RPAs which we call them now until they come up with another name. The rules for flying your RPA, some sample of a mapping mission and the associated processing with it. All right, so I'm going to try to get underway with this.
It's upside down.
Oh, okay. That's why my first drones always came out of the sky. For some reason I had them upside down most of the time. Okay, so as I said, I'm going to keep this very simple because I'm presenting it. And we're just going to go through what generally surveyors will be using drones for. So there's two types, the standard ones out there. There's fixed wing and there's multi-rotor. Fixed wings basically fly like a plane and drop like a stone when they run out of power. Multi-rotor is much the same, but at least when you take your hands off the control, they will generally hover there, which is good for pilots like myself. So the fixed wings are the original RPAs used in surveying. Traditionally, they were either launched from a catapult or manually propelled, so throw it up in the air, or from a catapult. Now, if you go onto YouTube and you Google YouTube catapult drones, you'll see some rather spectacular crashes, and usually quite expensive crashes as well. The fixed wing ones, they required room to land, so as I come across later, I'll be talking about the benefits of the multi-rotor. They're quite expensive and they're favourite food for wedge-tailed eagles. Now, for those of you that actually use fixed wing drones, put your hand up if you've had them attacked by an eagle. Okay, well there's a few around. So each one probably, if it wrecks the whole thing, it's probably worth about $20,000 or $30,000. So as I said, you've got to be a little bit careful where you're flying. And now, for a lot of those reasons, that's why I don't have a fixed wing one. The main reason I don't have a fixed wing one is I can't fly planes. I was hopeless. I tried very early on and I didn't know whether it was coming towards me or going away from me, and they just crashed all the time. So I went for the multi-rotor, which is the one we see here. So the multi-rotors, they're more recently used by surveyors. They can take off and land vertically, really good for me. They can hover, again good if you're not quite sure what's happening. You can just take your hands off the controllers and likely just hover there waiting for you to make up your mind. And they're also good for not just doing mapping, but also for videoing structures, like might be for power lines. When we had to do our test, we had to do we had to plan a mission that was going to go and monitor or take photos of solar panels on an RSL club. So it can be used for all sorts of things like that. They're also quite inexpensive and easy to use. As I said, I'm really clumsy when it comes to flying stuff, but I can fly one of these things, no worries at all. The one I actually use is that one there. It's called a Phantom 4 Pro. It's about $2,000, or you can probably get it on special JB Hi-Fi for about $1,800. So they're very inexpensive, and again, when you see the sort of the resolution and the quality you can get out of them, you'd be surprised at how they compare with some of the really, really expensive ones. Also, I've had hawks and crows basically laugh at mine instead of actually attacking them. They for some reason, they don't seem too concerned about the actual the multi-rotor one. Having said that, I haven't actually had an eagle look at one yet, so we'll see what happens. So one of the big things, if you're going to get a drone, you can, as I said, duck down to Harvey Norman or JB Hi-Fi, grab one for $2,000, but then you've got a few rules that you've got to cover. Now, CASA is the governing body for anything that basically flies in Australia, And in a couple of years ago now, they actually softened the rules a little bit for using drones. So the actual drone that I've got, as long as I don't disregard some of the major rules, then I can quite happily fly it and actually charge people money for my services. So I'm just going to take you through. So with CASA, it's got some really interesting stuff on the website, and they've got some rules here. And a lot of them are common sense. You've only got to fly during the day, keep your drone within line of sight. You can't fly over 120 metres. You've got to be at least 30 metres away from other people. Don't go near where there's a bushfire and something like that to have a look, because there's going to be other planes flying quite low near you. You can only fly one RP at a time. I'm lucky to fly one at a time. And if your drone weighs more than 100 grams, which is basically pretty well any drone, then you've got to stay away from airports. Now, that's not to say you can't actually... I'll just see if I can pause that for a sec. I'll just let it run through again. Come on. Okay, but then there's some other rules. Now, having done all this, or having seen all this, if you do actually get licensed, now I'm actually a licensed drone pilot, so I can actually apply to actually break some of those rules slightly. But these are just general rules that as long as you follow these rules, you literally don't have to have a drone license to actually to do a survey. Having said that, you should also talk to your insurance company. They might say, well, that's all well and good, but we still would like you to be a licensed pilot to be able to get insurance in case for some reason your drone did actually go and knock someone on the head or go out of control. So when we're planning a mission, the first thing I do, if somebody says, hey, can you go and fly a certain area? I go onto I've got another app on my phone, or I've got on the internet, on the web, you can actually go and run a thing called Can I Fly There? So just Google search Can I Fly There? And what it'll do is, first off, it'll actually try to find exactly where you are, which is great if you're sitting in the office because you don't want to fly there anyway. But it'll actually tell you whether you can physically fly there or whether there's restrictions. So if your office is right by the airport, the first thing it's going to do is say, no, sorry, you can't do that. So what you basically do, it's a little interactive map, and you can move to where you're going to fly, and then you can click there and it'll actually tell you whether it's okay or not. Again, assuming that you're going to keep to all the rules that it sets for you. So that one there was in Queensland, just near Innisfail. I was showing a guy how to use a drone, and we went and surveyed a mate of his cane farm. Okay, so we went there. I ran this, yep, that was all okay. So the next step is to get some sort of a surround. Now, with a lot of the apps you can do now to do your flight planning, if you can get a KML file or something like that, then you can use that as part of your flight planning. So you can either duck into Google Earth yourself, or you can get a KML file from the client. So once you've got the KML file in Google Earth, what I would normally do then is plan where I'm going to put some what's called ground control points, which are basically just known points for doing for being able to position the drone survey. Now, some of the more fancy drones have accurate positioning in them, so you don't actually need these ground control points. As I said, I'm not using really fancy ones. I'm using fairly low-cost, off-the-shelf ones, so I go and put my own targets in. So there was an example there. So I've got where I want to put some targets in. You can see it's sort of a fairly good a grid. The spacing of the grid sort of depends on how high you're going to fly. So if you're going to fly fairly high, you can have them further apart. If you're going to fly a lot lower to the ground, then you keep them closer together. Then once we've actually got the KML file generated, we can actually bring it into an app that'll run on the computer, or it'll actually run on the iPad a bit later. There's quite a few different ones out there. The one I use is called Drone Deploy. Now this one will actually do all the processing for you if you want to submit it up online, or if you don't want to do that, it will basically just design your flight plans for you, and then you can do the processing yourself. And I basically like to do the processing myself. Okay, right, so we've got the KML file. Hang on, just grab my notes here. Setting up. Okay, right, so basically what happens is with this software you can put in things like the height you want to fly, the forward overlap and the side overlap, which is important to make sure you've got sufficient overlap because that's what creates the three-dimensional model, and also the flight line directions. So it's probably a little bit hard to see there, but over on the left it'll actually say that I want to fly at 75 metres, so 120 metres is the highest I can fly. But obviously the closer you go to the ground, the better resolution you're going to get. You can actually spin around the flight lines. Basically, you know, if it's a bit windy one day, you might want to be flying into the wind. I've managed to fly in a gale pretty well one day. I had to get the job done. And it seemed to take 1,000 photos going into the actual wind and about 10 coming out of the wind. So poor little thing was just managing to move forward. It also will calculate, and up on this, it'll actually calculate how long the mission's going to take, the area you're going to cover, the number of photos, and how many batteries it's going to use. So it's very, very simple. Now this one's linked, this software is linked into what type of drone I've got, so I don't have to put any parameters in. It already has been told that that's the drone I'm going to use. Okay, so next thing you do is we go out in the field and we're going to set the actual drone up. So here's my mate up in Innisfail. You can see he's from northern Queensland. You can see the sort of safety boots he's wearing. So there's the drone, absolute monster, that one. As I said, this is just a stock standard one that you can buy in any shop. So we start off very basic, very, very easy to put together. You put the rotors on, if it takes off and the rotor fell off, you didn't put the rotor on properly. These ones are actually a bit different to the original ones. They go in and they clip and have a bit of a lock in them, whereas the old ones you used to just spin them around. So if you didn't spin around too much, sometimes they'd sort of fall off, which was a bit exciting. So we'll just, come on Wally, hurry up. Right, okay, so you can see here he's pretending that he's actually checking it. Nice, neat little package, very easy to cart around with you. So again, you're not taking some big monster thing with a catapult or anything like that. Very simple little controller. Again, simple, non-simple. It's got a little bracket, and that's a little iPad mini. So you basically, your control is just running on a little iPad mini. So again, this stuff's really, really cheap. The iPad mini cost me $400, I think. Okay, so that all plugs in. And then once the drone's actually turned on, then it'll sort of connect. Now, what I'll do, see if I can just, it's almost like I was training him. Oh, yeah, that's right. No. Oh, here we go. Okay. Okay, so no, I will actually simulate this in a second anyway. So basically, it's going to take off, and as I said, I'll actually simulate what's going. But you can see it's very, very simple. It just takes straight off vertically. It will go up, and then it'll go to where the first point is. Now, that wasn't a very good day for doing drone stuff. It was a little bit windy and quite dark. Now, this next one basically simulates what he saw on the screen. So we had our flight plan, and you can actually run it as a simulator. So you can it's even that idiot-proof, you can even see if it's going to work. The very first time I did a drone and I put it in a simulator mode, I had it outside. There was an earlier version of this, and it was at night time. I probably shouldn't have done that. I had the blades on too, shouldn't have done that either. So anyway, it was a long time ago, and I pressed the simulate button and I heard it fire up and I saw it go up into the air. And it went up, I don't know how far it went up, I almost lost sight of it. But then it did actually run out of batteries and then it came down. But luckily at the time, we weren't quite in drought, and we had a really big set of blackberry bushes and it landed in that, so all was good. So yeah, so if you're going to simulate something, take the rotors off. I can go through all the things what you've got to do wrong. Okay, so basically when he's actually hooked it in, over on the bottom right-hand side, there was a little save button, so it's calculated everything. So what that does, it saves it, and then it connects to the drone. So the drone's got to get this GPS lock, and once the GPS lock is happy, it'll then say drone connected. It'll have a green light. Red light's bad, green light's good. And then you go over to the right and you click a button and it'll load the mission into the drone. Okay, tick, 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 that must be good. And then the little button on the bottom right says, yep, I'm ready to go, press that. So when you do that, at that point, that's where the drone goes up into the air, and it goes up 50 metres or whatever, and then it'll start moving over to where it's got to go to. Now, at this point here, at that point there, it starts to... Oh, there you go, it's still talking. It actually starts taking the photo. So up on the left, what you can actually do is it's monitoring things like speed, it's monitoring how many photos it's taken, and when it comes to the end, went a bit quick, when it comes to the end, it'll automatically come back and it'll land. Pretty hard, isn't it? So once it lands, in this one here, it then says, okay, what would you like to do? Would you like us to process it, or do you want to process it? So if you want them to process it, you can upload the photos, or what I do is I say, no thanks, I'd rather do it for free. I mean, I'd rather not pay for it. So I grab the micro SD card out and I put it in my computer and then I process it myself. So as I said, it's amazing how easy it is. Now, the processing can be done in a number of ways. You can do the processing online. There's two main processing softwares I seem to see out there, which is Pix4D and Agisoft. The reason I went Agisoft is probably because it was the first one that I came across that I sort of understood. So it's fairly easy to use. Lee probably won't want to hear this, but I think I've used it for about 3 years now and I've never had to pay for an upgrade. Yeah, and as I said, there's probably as many people using Agisoft as there is using Pix4D. Right, so with the processing side of it, this is sort of the steps that you'd use. You'd firstly add the photos, you delete unwanted photos, set up your coordinate system, align the photos, import and reference the things, and so on. So what I do is just quickly take you through some of these options. So the first thing we do is we add and filter the photo. So you can imagine if you've gone out and you take some happy holiday snaps, you put them on the computer, what's the first thing you're going to do? You're going to go through and you're going to delete all the ones you don't want, or the ones that you took of somebody else that you probably shouldn't have. So basically, what we do here is we just read the photos in. So we just select the folder. Okay, now the neat thing here is that the GPS has time-stamped or position-stamped all of the photos. So you can see those little blue dots. That's basically where the photos are. It's not super accurate. It's probably plus or minus 10 metres, but it does give you a bit of an idea. So what I could do is I can see those 2 points are obviously when it was down on the ground. Now on the photos on the right, I'm having a bit of a look through and just seeing if there's nothing else that's there. Occasionally you might find one where it maybe something's happened and it's flicked up and you can see a picture of, the horizon rather than the actual ground. The next thing we do is you can actually estimate the image quality. So in other words, if it's gone past something or all of a sudden it's had a gust of wind and the photo's a bit blurred, it'll go through and it'll actually find out any photos that aren't good enough quality, because you don't want to put bad quality photos in there because it's harder for it to try to stitch it together. Okay, right, so the next thing we do is the coordinates. Actually, there's a slight step sort of between those two slides you probably didn't see, mainly because I didn't put it in. But the photos themselves are in latitude, longitude and height, and what we do is we would convert them to MGA coordinates, the local coordinates. Now the main reason for that is that when I went and surveyed those points, I had local coordinates, or MGA coordinates, sorry, for those points, and I wanted to be able to import them into the actual job to be able to manipulate the images. Also, there's an option that you just align the photo. So all it does is it goes through and it tries to match pixels on the photos to put together a model, and then we're at a point where we can read in our ground control points and identify them on the photos. So I'll just do a quick look at that. So again, it's just a simple CSV file. There's nothing really complicated about this. There's lots of options you can use if you want to, but you don't have to be Einstein to be able to get through and to get a really good result out of these programs. So what I've got, so these are the ground control points. So these are the little readings that I took on some tiles. Now even the tiles, they're really, really complicated. You go down to Bunnings and you buy these little black and white tiles as if you're going to be doing some lino on the floor. The poor guy down to our local Bunnings thinks I'm either the slowest bloody builder in the world or I make lots of mistakes because I'm always going in and just buying one little box of them. But basically what it is, see there it is on the ground. So what I do is I position it in an area, and then what I'm doing now is on a couple of the photos, for each one I'm identifying it, and then it'll actually go and filter and show me the other ones, and then I can move all the points onto them. So I'm basically referencing the actual the photos. Now, once you've done that on the photos, it's a little bit time consuming, but that's all right. I've got no life. So what you do then is you go optimise, and then you update, and then you optimise. So what that then does is that basically, probably a really fancy word for it, but fits it all together really nicely, and you get an idea of your errors called residuals. So once you've got that, then you've got basically your model as accurate as you're going to get it. And you get a good report from it as well. Okay, so there's the point cloud. It's now been, that's the initial points from the actual photos. We haven't created the point cloud yet. So what we do now is we then generate the point cloud. Now, there's things you can do as you go through. So we generate the point cloud. But then what it does is it basically creates a point cloud of everything. So it'll be the tops of the trees, the top of the cow, whatever. And you may not want to contour the top of the cow. And there were a few cows there. Just ignore that brown bit. That's not supposed to be there. That I just went into another option before I did that. Right. So basically what we need to do is, now that we've got that point cloud, we can run an option which we'll call classify points. So in other words, this option here will classify ground points, which means it'll go along, it'll be looking at the terrain, and then all of a sudden if it jumps up, it goes, oh geez, I don't think that should be part of the ground. And you can see what it's done is it's pretty well picked wherever there's trees, and it's put it into a different layer. Now the neat thing about that is you've got, you can then only create your mesh from the other layer, same as if you're doing a normal survey in 12D. Also you can classify, you can put your own little, you can highlight other areas. See that little green area? I just went around a tree, and then I just said classify that as a tree. So you can put it into any sort of layer you want. Okay, so once you've done that, she stopped? Yep. Okay, so now what we do is we create the mesh. So again, all this stuff's pretty similar to what you do in 12D, right? Except for all the, the photos part. So what we've got now is we're going to generate the mesh from the point cloud. Okay, we just did it from the ground ones. And you'll see there's now generally a survey like that, you'll get about 60, 70, 80, 90 million points. So you probably want to have a slightly different version, the 5 million point version. When you get the triangles, a really great little option to decimate the mesh. So what it'll do is it'll basically, if you've got 10 million triangles in there, it'll filter it out to say however many you want. So it'll still maintain the break lines fairly well, but it'll sort of filter out any of the areas that are within a certain tolerance. Now, hang on. Now with this one here, once we've done that, then it's really then a matter of now getting out all the rest of the processing. Now you can actually I will try to just it's run ahead of me there a bit. Hang on, I saw it there a second ago. Here we go. I'll just come back a bit. Okay, I'll just pause here. Okay, so what I tend to do when I finish the day, say I've got a fairly big job, I've got a 350 hectare solar farm to start on Wednesday, so it's not, I'm not just using it as a toy for little jobs, it's a fairly comprehensive sort of stuff. But each day what I'll often do is I'll try to process and get it to a point where I can then run this option while I go to sleep. So what we've got is we've done the things where it requires a bit of editing, and now what I'm going to do is you can have a batch process that'll go through all the other bits and pieces. So it'll build up the texture, it'll build up an it'll create the imagery, it'll export your points, so it'll create a file of last points or whatever points you want. There's lots of different options. It'll create a GeoTIFF file, so if they're really accurate imagery. It'll create, you can do all sorts of things, models, and it'll generate reports. Now this is and now obviously you get all those sorts of files out here. And lastly, this is sort of a KMZ file that came out of that job. So you've always got to start off right out like this. So it's even better to just flick Google Earth on and off to show you the difference in the quality. So we mentioned that cow. Yeah, man. So it's not bad resolution from 75 metres up for a little thing you can buy down at JB Hi-Fi for, $2,000 or $19.99 on special this week. Okay, so basically this is the sort of stuff we can get. Now, every time I look at a drone job and I think, oh man, that would have taken me ages to walk that. And you're sitting in your hammock with your pina colada and your keeping an eye on the drone, of course. With your control, and you're thinking, gee, this is really good. This is a great way of doing surveying. So luckily I'm old enough to appreciate just how easy you young guys have got it now. So, but as I said, look, that's drone surveying. It is very easy. As I said, I'm living proof of that. It's certainly got lots and lots of applications. Now that was just mapping. But as I said, surveyors are now using drones to work for real estate agents to do videos of things, and I'm getting told to shut that up. But what's that? Oh. Okay, so anyway, so hopefully that's given you a bit of an insight into it. As I said, there's nothing really complicated about it. If you want to have a chat at all about it, I'm more than welcome to sort of help you out. I'm also a teacher at the Canberra Institute of Technology, so I teach the students this as well. So it's certainly something that every surveyor should have a drone in the back of their car. It's just another basically tool in your toolbox. Okay, thanks for that.